Welcome to the fascinating world of optoelectronics. In this video, we'll explore how light and electronics come together to create groundbreaking technologies. Optoelectronics is a branch of science and engineering that focuses on the study and application of electronic devices that source, detect, and control light. From the screens on our smartphones to high-speed internet connections, optoelectronics is at the heart of many modern innovation. Let's embark on a journey to understand the basics, applications, and future of this exciting field, starting with what optoelectronics really means. Optoelectronics combines optics and electronics, focusing on devices that either produce or interact with light. This includes everything from LEDs and lasers to solar cells and photodetectors. The field bridges the gap between the world of photons and electrons, allowing us to manipulate light for communication, energy, and information processing. Understanding optoelectronics opens the door to a wide range of technologies that impact our daily lives, making it a cornerstone of modern science and engineering. Roots of optoelectronics can be traced back to the discovery of the photoelectric effect by Albert Einstein in the early 20th century. This phenomenon showed that light could be converted into electricity, laying the foundation for devices like solar cells. Over the decades, advances in materials science and semiconductor technology have propelled optoelectronics into the mainstream, leading to the development of lasers, LEDs, and fiber optics. Today, optoelectronics is a rapidly evolving field with applications in countless industries. The core of optoelectronics is the interaction between light and electronic materials. When light strikes certain materials, it can generate electrical currents or cause electrons to move between energy levels. This process is harnessed in devices like photodiodes and solar cells. Conversely, applying electricity to some materials can cause them to emit light, as seen in LEDs and lasers. This two-way interaction is what makes optoelectronics so versatile and powerful in technology. Optoelectronic systems rely on various light sources, with LEDs and lasers being the most common. LEDs, or light-emitting diodes, are used in everything from indicator lights to large display screens. Lasers, on the other hand, produce highly focused beams of light and are essential in applications like barcode scanners, medical devices, and fiber-optic communications. The choice of light source depends on the specific requirements of the application, such as brightness, wavelength, and coherence. Light detectors are crucial in optoelectronics, converting incoming light into electrical signals. Photodiodes, phototransistors, and charge-coupled devices, CCDs, are common types. These detectors are found in cameras, remote controls, and even solar panels. Their sensitivity and speed determine how effectively they can capture and process light, making them vital for applications ranging from imaging to energy harvesting. Semiconductors are the backbone of optoelectronic devices. Materials like silicon, gallium arsenide, and indium phosphide are engineered to have specific electronic and optical properties. These materials can efficiently absorb or emit light, making them ideal for use in LEDs, lasers, and detectors. Advances in semiconductor fabrication have enabled the miniaturization and integration of optoelectronic components, paving the way for more compact and powerful devices. Light-emitting diodes, or LEDs, have revolutionized the way we light our homes, offices, and cities. They are energy-efficient, long-lasting, and available in a wide range of colors. LEDs are used in everything from traffic lights and televisions to smartphones and decorative lighting. Their low power consumption and durability make them a sustainable choice for modern lighting solutions, contributing to energy savings worldwide. Lasers are a cornerstone of optoelectronics, producing highly focused beams of light with remarkable precision. They are used in a variety of applications, from cutting and welding materials to performing delicate eye surgeries. In communication, lasers transmit data over long distances through fiber-optic cables. Their unique properties such as coherence and monochromaticity make lasers indispensable in both industry and research. Solar cells, also known as photovoltaic cells, convert sunlight directly into electricity. They are a key technology in the transition to renewable energy, powering everything from calculators to entire buildings. Advances in materials and manufacturing have made solar panels more efficient and affordable, driving their widespread adoption. Optoelectronics plays a vital role in the ongoing development of solar energy solutions. Photodetectors are essential for sensing and measuring light in various applications. They are used in cameras, scientific instruments, and safety systems. By converting light into electrical signals, photodetectors enable devices to see and respond to their environment. Their performance depends on factors like sensitivity, speed, and wavelength range, making them a critical component in optoelectronic systems. Fiber-optic technology uses thin strands of glass or plastic to transmit light signals over long distances. This allows for high-speed data transmission with minimal loss, making fiber optics the backbone of modern telecommunications. Optoelectronic devices like lasers and photodetectors are key to sending and receiving these light signals, enabling everything from internet connections to cable TV. Optoelectronics is at the heart of modern display technology. From LED TVs and computer monitors to smartphone screens, optoelectronic components create vibrant, high-resolution images. These displays rely on precise control of light emission and detection, allowing for stunning visuals and interactive experiences. The ongoing evolution of display technology continues to push the boundaries of what's possible in entertainment and communication. Optical technology has greatly benefited from optoelectronics. Devices like laser scalpels, optical sensors, and imaging systems rely on the precise control of light. These technologies enable minimally invasive surgeries, accurate diagnostics, and advanced treatments. Optoelectronics continues to drive innovation in healthcare, improving patient outcomes and expanding the possibilities of medical science. From smartphones to smart TVs, optoelectronics powers many of the devices we use every day. Touchscreens, cameras, and display panels all rely on the interaction between light and electronics. As technology advances, optoelectronics enables thinner, brighter, and more energy-efficient devices, shaping the future of consumer electronics and enhancing our digital lifestyles. In industry, optoelectronics is used for automation, quality control, and safety. Sensors detect changes in light to monitor production lines, while lasers are used for cutting, welding, and measuring. These technologies increase efficiency, precision, and safety in manufacturing environments, making optoelectronics a key driver of industrial innovation. Modern vehicles are equipped with optoelectronic systems for lighting, safety, and entertainment. LED headlights, optical sensors for autonomous driving, and advanced display panels all rely on optoelectronics. These technologies enhance visibility, improve safety, and provide drivers with real-time information, transforming the driving experience. Optoelectronics plays a vital role in security systems, from surveillance cameras to motion detectors. Infrared sensors and night vision devices allow for monitoring in low-light conditions, while high-resolution cameras provide detailed imagery. These technologies help protect homes, businesses, and public spaces, making our environments safer. Optical communication systems use light to transmit information over long distances. Fiber-optic cables, lasers, and photodetectors work together to send data at incredible speeds. These systems form the backbone of the internet, enabling global connectivity and supporting the rapid exchange of information in our digital world. Space exploration relies heavily on optoelectronics. Satellites use optical sensors for imaging and communication, while lasers are used for precise measurements and data transmission. These technologies enable scientists to study distant planets, monitor Earth's environment, and maintain reliable communication with spacecraft. Optoelectronic sensors are used to monitor air and water quality, detect pollutants, and measure environmental changes. These devices provide real-time data that helps scientists and policymakers make informed decisions about environmental protection. Optoelectronics is essential for tracking climate change and ensuring a sustainable future. In laboratories, optoelectronic devices are used for precise measurements, imaging, and analysis. Instruments like spectrometers, microscopes, and laser systems rely on the interaction of light and electronics to explore the microscopic world. These tools are indispensable for advancing scientific knowledge and discovery. Modern agriculture benefits from optoelectronic sensors that monitor plant health, soil conditions, and crop growth. Drones equipped with optical cameras provide aerial imagery, helping farmers optimize their practices. These technologies increase efficiency, reduce waste, and support sustainable farming. Optoelectronics contributes to energy efficiency through technologies like LED lighting and solar panels. These devices reduce energy consumption and reliance on fossil fuels, supporting global efforts to combat climate change. As optoelectronics continues to advance, it will play an even greater role in building a sustainable future. The field of optoelectronics is constantly evolving, with new technologies emerging all the time. Quantum dots, organic LEDs, and integrated photonics are just a few examples of innovations that promise to revolutionize the industry. These advancements open up new possibilities for faster, smaller, and more efficient devices. Despite its many successes, optoelectronics faces challenges such as material limitations, manufacturing costs, and integration with existing technologies. Researchers are working to overcome these obstacles by developing new materials, improving fabrication techniques, and designing more efficient devices. Addressing these challenges is key to unlocking the full potential of optoelectronics. Looking ahead, optoelectronics is expected to play an even greater role in our lives. Trends like miniaturization, increased integration, and the rise of smart devices will drive demand for advanced optoelectronic components. As the Internet of Things expands, optoelectronics will enable new forms of connectivity and automation. Artificial intelligence and optoelectronics are increasingly intertwined. AI-powered image recognition, autonomous vehicles, and smart sensors all rely on optoelectronic devices to collect and process data. This synergy is driving rapid advancements in both fields, enabling smarter, more responsive technologies. Wearable devices like smartwatches and fitness trackers use optoelectronic sensors to monitor heart rate, activity, and environmental conditions. These sensors provide real-time feedback, helping users stay healthy and connected. As wearable technology evolves, optoelectronics will enable even more advanced health and wellness features. Optoelectronics is a key enabler of smart home technology. Light sensors, smart lighting, and optical communication systems allow for automated control of home environments. These devices make homes more energy efficient, secure, and comfortable, while integrating seamlessly with the broader Internet of Things ecosystem. Augmented reality, AR, and virtual reality (VR) devices rely on optoelectronic components for immersive experiences. High-resolution displays, optical sensors, and tracking systems work together to create realistic digital environments. As AR and VR technologies advance, optoelectronics will continue to enhance their performance and realism. Educational tools and platforms increasingly use optoelectronic technologies. Interactive whiteboards, projectors, and digital displays make learning more engaging and accessible. These devices leverage the power of light and electronics to deliver information in dynamic and interactive ways, transforming the classroom experience. Artists and designers are embracing optoelectronics to create stunning visual displays and interactive installations. LED lighting, laser projections, and digital screens allow for new forms of artistic expression. The fusion of technology and creativity is opening up exciting possibilities in the world of art and design. Entertainment industry relies on optoelectronics for everything from stage lighting and special effects to high-definition displays and projection systems. These technologies create immersive experiences for audiences, whether at concerts, theaters, or home cinemas. Optoelectronics continues to push the boundaries of what's possible in entertainment. Transportation systems use optoelectronic devices for signaling, navigation, and safety. LED traffic lights, optical sensors in trains, and advanced lighting in airplanes all rely on the interaction of light and electronics. These technologies improve safety, efficiency, and passenger experience across various modes of transport. Banking and security systems use optoelectronic devices for authentication, surveillance, and data protection. Optical scanners read fingerprints and iris patterns, while secure communication channels rely on optical encryption. These technologies help safeguard sensitive information and ensure secure transactions. Optical data storage devices like CDs, DVDs, and Blu-ray discs use lasers to read and write information. These technologies have enabled the storage and retrieval of vast amounts of data, revolutionizing the way we access music, movies, and software. As data needs grow, optoelectronics will continue to play a role in next-generation storage solutions. Retail environments use optoelectronic devices for barcode scanning, digital signage, and security systems. These technologies streamline operations, enhance customer experiences, and improve inventory management. Optoelectronics is helping retailers adapt to the demands of a digital economy. Smartphones, tablets, and computers all rely on optoelectronic components for displays, cameras, and sensors. These devices enable high-quality video calls, photography, and interactive experiences. As communication technology evolves, optoelectronics will remain at the forefront of innovation. Robots use optoelectronic sensors for vision, navigation, and object detection. These sensors allow robots to interact with their environment, perform complex tasks, and operate safely alongside humans. Optoelectronics is driving the development of smarter, more capable robots for industry, healthcare, and everyday life. Military and defense applications rely on optoelectronics for surveillance, targeting, and communication. Night vision goggles, laser rangefinders, and secure optical links enhance situational awareness and operational effectiveness. These technologies are critical for modern defense systems. Smart city initiatives use optoelectronic devices for intelligent lighting, traffic management, and environmental monitoring. These technologies help cities become more efficient, sustainable, and livable. Optoelectronics is at the core of the smart infrastructure that will shape urban life in the future. Optoelectronics is all around us, from the remote controls we use to change the channel to the automatic doors at the grocery store. These devices make our lives more convenient, efficient, and connected. As technology continues to advance, optoelectronics will become an even more integral part of our daily routines. Career in optoelectronics offers exciting opportunities in research, engineering, and technology development. Universities and companies around the world are investing in optoelectronics education and training. Whether you're interested in designing new devices or advancing scientific knowledge, this field offers a rewarding path for curious minds. As we've seen, optoelectronics is a dynamic and rapidly evolving field that touches nearly every aspect of modern life. From communication and energy to healthcare and entertainment, the fusion of light and electronics continues to drive innovation. The future holds even greater promise as new materials, devices, and applications emerge. Stay curious and keep exploring the world of optoelectronics, where light truly meets technology.